Well, good morning. Welcome to Managing Programmers. I'm Doug Crockford, and these are my qualifications for doing this talk. I am a programmer. I have been a manager of programmers and a manager of programmers. And what I'm going to share with you today is what I have learned in trying to manage programmers, which is a difficult thing. One controversy we can start with is, what do you call these people? There are a number of terms which are sort of interchangeable, but all seem to have special meanings. The oldest and the one that I prefer to use is computer programmer. Grace Hopper, I think, gave us that one. The highfalutin of these titles is computer scientists, which is an aspirational title. There's surprisingly little science in computer science, unfortunately. But one thing you can be certain of is that anyone who calls himself a computer scientist probably thinks he's much smarter than everybody else on this list. Software engineer is another aspirational title. We don't really have engineering in software because we don't have physics. Physics is the thing that keeps engineers honest, and we don't have that. And so we hope to be doing engineering, but we don't really. Microsoft has popularized the idea of calling them software developers, and a lot of them call themselves that. I don't know why. Some of them are just coders. Everybody else on the list thinks they're smarter than the coders. And then there are the hackers. Hacker used to be a respectful term about people who are working in this stuff, but it's been corrupted by the media to mean criminal. And there are some programmers who continue to call themselves hackers because they are so out of touch with reality that they're not aware of what people think it means. You probably don't want to be hiring them, either kind of hacker. One of the things that makes it really difficult to manage programmers is that they are creatives. And you have the same problems in managing programmers as you would have managing musicians or managing artists, anybody who's doing really creative work. And in fact, I would contend that programmers are the most creative of all of the creative arts. And that might sound unlikely because they don't look like creative people. They don't dress certainly like creative people. But they are creative in the most important sense of creation, in that they are like gods. They have the gift of creation. They can cause stuff to come into existence just by saying it, or not by saying it, by typing it. And well, the things they have to say are really long and complicated, and they don't always work, but sometimes it works, and they have the gift of creation, and they are like gods. They are little gods, little, not great gods, little incompetent gods, but still gods, and that's a wonderful thing. That affects you. When you have that power, it makes you different than everybody else. And so programmers are not like the other kids. And if you try to manage them like the other kids, you'll fail because they're different, and you have to be aware and understanding and respectful of that difference. Otherwise, you're not going to use them properly. In order to understand programmers better, you want to go to the funny pages. So every morning, you want to read Dilbert. Oh, that's less funny when you can't read the whole thing. Anyway, Dilbert is about what it's like to be a god working in a company and being managed by incompetent managers. It will hurt reading this. It will sting, but they think it makes sense. And so you need to be reading this in order to understand how they think about what you're doing. You also want to be looking at XKCD. And you'll look at this and go, what the hell is that? You know, it's not even drawings. But this guy is a programmer. He hasn't been doing much programming lately, so the more recent strips aren't that relevant to what we're talking about here. But the older ones do and have a lot of power, that in an argument, programmers will cite XKCD the way Christians will cite Bible verses. So you need to understand this stuff. Now, in conventional management, there's this idea that if you can't measure it, you can't manage it. I've heard Peter Drucker described as the guy to come up with, and I haven't found any evidence for that because Drucker is a really smart guy, and this is really stupid. I mean, it's obviously not true. There's all sorts of stuff that we can't measure that we can manage. And we've been managing for a long time, long before we had measurement tools. We built pyramids without having the accounting techniques that are part of what we currently call metrics. One of the problems with metrics is if you focus on trying to achieve a number rather than trying to understand a complicated system, you can very easily find situations where you're meeting your numbers but actually destroying the operation. And that happens in business all the time. And it's something that you can't do very effectively with programmers. So you would think that programming would have lots of metrics in it because we're in computers. Computers are the things which give us metrics, but there's not much in what we do that is measurable. You can measure things like lines of code or the rate of introduction of bugs or the rate of fixing bugs, and you can try to create incentive systems or punishment systems which are keyed to these numbers, and they will all fail because that's not how things work. You know, if you're trying to optimize lines of code, you're going to get more crappy lines of code. Lines of code are not a meaningful measure because it's not like you can predict how many lines of code are going into a system and measure completeness by what percentage of the lines have been completed. That is completely misleading. And in fact, often the best thing you can do to a software system is to remove lines of code. Any day I can remove a lot of code from a system, I consider it to be a good day. But if you're looking at it strictly in terms of metrics, that's insane. Why would you take something out? That means we're not making progress. It's because counting lines of code does not give you a clear picture of progress. Also, these things can be gamed. Like if you incent people on the introduction of bugs, you're going to get more bugs. And if you punish them for introduction of bugs, you're going to find bugs are not going to get reported. And so the metrics don't work. So what you really want to be measuring is the actual number of defects, the number of actual defects, the things that are actually wrong with the code. And we want to use that to understand the total remaining effort to completion. And we haven't a clue as to how to determine either of those numbers. And so without those metrics, all of the other metrics are completely meaningless. And the reason we don't have these metrics is because programming is not manufacturing. Manufacturing, which is something where metrics can be very effective, says we're going to do the same thing over and over and over again, and we can look at the efficiency by which we do those things over again. We can measure the quality of the things that we make over and over again. But in every software project, we're making something usually for the first time, the only time it's ever been done in that way. And so we don't have that kind of experience that you have in a manufacturing process to give you reasonable metrics. So let's talk about fraudulent metrics for a moment. There's a sense, or folklore, that there maybe is a 10-to-1 difference between the productivity of programmers. You've got a really good programmer, he's a 10, he does 10 times as much work as a 1. Or he has 10 times the value as the other one. And because we don't have metrics for the other things, we have no way of knowing if this is true. It seems like it's true, that you can look at a good programmer, a bad programmer, and go, well, that guy must be 10 times better than that one, but we don't know. But let's suppose, hypothetically, it is true, that you actually have someone who's 10 times better than the other one. Are you going to pay this guy 10 times as much? No, of course not. We have this myth that that salaries are based on performance or on contribution. No, salaries are determined by the ability to negotiate salary. And there's some people who are really good at that. And we call them CEOs. And I've known CEOs who seem to not be good at anything else, but they're really good at negotiating their salaries. The rest of us tend to be focusing more on other things. If you want to be making more money, that's the thing you need to be focusing on. All of that other stuff is in the noise, literally. It's not what determines it. So this is Wally. Wally is a co-worker of Dilbert. Wally determined some years ago he is not going to do any more work. So he goes to the office, he drinks coffee, he occupies space, he attends meetings, and that's all he does. And he is very proud of that. So he's not even a 1. right? He's slightly negative because he is taking time away from the other people on his team. You know, in order to look busy, he needs to be acting as a vampire, going around confusing or making promises to other people that he's not going to deliver, just being in the organization. This is the Tasmanian Devil. Managers love this guy. High energy, lots of passion, total commitment. You tell him to do something, he'll go and do it. He's just wild, great attitude. But he causes chaos everywhere he goes. Everything he touches turns to crap. But he touches a lot of stuff really fast, and he looks to be amazing. Most managers will think this guy's a 10, he is a minus 10. He is actually creating lots of work for everybody else to do. But he makes his milestones. He delivers constantly. So one of the things that makes it difficult to be reviewing programmers is we literally don't know which are the good ones and which are the bad ones. We cannot generally tell the difference. So programming is not manufacturing, it is discovery. The reason we can't manage it in terms of, well, write these lines of code until you get enough lines, then you're done, is because we don't know which lines to write. And we find that out in a process of trial and error. It's discovery. And so that makes estimation hard because it's hard to ask a question, how long will it take for you to find something? Because you have no visibility on all the issues that are obscuring it. And software tends to be very, very complex, and that complexity conceals the best way to get the thing that we're trying to build. And lacking that stuff, it's a trial and error system, and we can't do better than that. It's been said by me that no functional specification survives first contact with reality. That the thing that we think we want is never the thing that we want. It's never in sufficient detail, never thought through well enough. That, again, it's this process of trial and error which needs to be perfected. And so we literally don't know what we're trying to make. So historically, we managed software development with something that's been called the Waterfall Model. We start by drafting a set of requirements, giving that to architects to do the design, giving that to programmers to do implementation, giving that to another team that'll do verification, and then giving it to another team to do maintenance. That each of these steps would be done by a different group of people. And the assumption was that the requirements team knows everything they need to do in order to do their work and so on. It turns out they don't, that there are things which will not be learned until we get to implementation or even maintenance that the requirements team needs to know and they don't have. And the same is true of design. Design needs to know things that are not discovered until the later phases. And so while this looks like a nice linear progression, there are actually big loops involved in this. And it's not clear what the iteration factor is on each of those loops. And so you get this thing where it starts to get exponential, and it can take an enormous amount of time. This kind of thing is very difficult to predict. So because of all that complexity, the way this is usually used is we assume that every phase knows everything they need to know and there will be no looping back, which never happens. But if you tell the truth, you'll never get your project approved. And so that was the assumption, and it doesn't work. So today we have a different model called Agile. And Agile has some improvements over the previous model. We now have one team doing all of the stuff. So the one team, and that team is doing all of those things at the same time. And so, and they're also working in much smaller increments so that the process of discovery is streamlined. So the process is better formulated for doing the engagement, but it's still not a perfect system. That they're able to more successfully take a small leap, but they have even less visibility than the waterfall about where we're actually going. And so it's very easy by taking small steps to go off the cliff because you don't see what's coming. And so it's not a perfect model. It is better than the waterfall model. One of the most important aspects of the Agile model is it comes with an admonition that you must disparage the Waterfall Model. And also, you must never criticize the Agile Model. And so because of that, the model itself is not getting better because we don't talk about how it's getting worse. And so what you tend to happen is, because of the lack of architectural foresight on each sprint, you're making less and less progress until finally it doesn't seem that you can get very much done anymore. So I think the best way to manage programmers is with directed anarchy. That micromanagement of programmers does not work. So what you want to do is give them very clear requirements and give them the authority, the autonomy to figure out the best way to accomplish it and get out of their way. So when you're looking at your programmers, how do you know who are the good ones, who are the bad ones, who is actually doing their work, who is not, who is contributing, who is causing a disaster within our own stuff? You know, one thing that you always find is eventually code becomes awful. It becomes the legacy thing. And how does that happen? Whose fault is that? Who's making that happen? You know, who on your team is writing the good stuff? Who's writing the bad stuff? How do you know? Relying on metrics doesn't work because the metrics don't work. So there's only one way I think you can know, and that's read the source. It amazes me how many software managers never look at the work of the people that they're doing. They're looking at secondary or tertiary reflections of the work, but never actually look at the work itself. Looking at the code can tell you all we can find out about what they're actually doing, looking at what they're actually doing. So looking at the source is so important. I think we should do it every day. So I'm an advocate of a practice in which we have daily code readings. Every morning we have the dailies. This is an idea that comes out of filmmaking. In a movie shoot, every morning you get the staff together to look at the film that we shot the previous day, because that's going to inform what we're going to do today. I want to do that with code. I want to look at all the code that we wrote yesterday. It should only take an hour. And we'll look at it and look to see, do we understand what we're doing? What are the questions that are going on? What are the problems? Is everything going to mesh when it comes time to integrate? We can do that much better if we're doing it every day. And if you're watching this process happening every day, you're going to have a much better sense of who actually knows what they're doing and who doesn't. So one of the main things you want to get into your code style is readability. You want the code to be highly readable so that everybody on the team can understand what the code is doing. If anyone is using coding practices which impairs readability, you want to stamp that stuff out. You want to have the stuff good because all of the value of what we're doing is in the code. And so we want to have the code at the highest quality as possible, and high quality code is readable. So how do you hire programmers? How do you tell if a guy who's walking in is any good or not? Interviews turn out to be an extremely poor predictor of performance for all jobs, and especially bad for programmers. Some places will ask trivia questions in puzzles, which I think is pointless, unless your job is to answer trivia questions. I don't see the point of doing that. Sometimes you'll have them doing exercises, be like asking a chef to make an omelet, but being able to make an omelet is not evidence that you want this guy on your line, right? That's a completely different set of skills. So what I want to do is do a code reading. So we ask the candidate to come in, and we're going to have him read the code the same way we read our code. What we want to see is what's the quality of his code, how well can he express what his code is doing, because if he can't communicate it to us, he's not going to be effective on our team. I want to see how he takes criticism. So if we suggest ways that he could have made his code better, I don't want him to cry. We'll see what happens. That'll have a lot to do with the quality of the candidate. So programmers are like gods, right? They're like superheroes who can make stuff simply by thinking about it and typing for a while. And like all superheroes, there's supervillains, there's super enemies that frustrate them as they're trying to do their work, in this case, create their creations. Oh, incidentally, so you've got this god who has a superpower who can make stuff for you, and then you tell them, I will pay you to do that. And they get giddy, like, oh, I can't believe it. You're going to pay me to, they love that. But they want to make good stuff. So the number one enemy is complexity. Computer programs are the most complicated things that humans make. And humans are not good at managing complexity. And as our requirements get more and more extravagant, it becomes harder and harder to write code which is actually going to work and be maintainable and be correct and all the things that we need it to be. And the problem is with complexity. That complexity is a very hard thing to manage. So a lot of a programmer's job is not doing the creation, it's not doing the typing, it's managing the complexity of the enormous task that they're given. And that's really hard. And it's something that most of us are not given direct training at any level for how to do, but it's something that's essential. The only thing that's effective in helping us to manage complexity is knowledge. Knowledge and experience, a deeper understanding of the domain and applying that to the solution, that is the only thing that works. Things that don't work are looking busy. Most managers are looking for looking busy. Turns out that doesn't help you manage complexity. Having a good attitude, managers love programmers with good attitudes. My experience is the best programmers have bad attitudes. I once talked to a manager who said, well, having a bad attitude isn't proof that they're going to be good, right? I said, well, no, of course not. And she said, oh, okay. So it's all right that all my guys have good attitudes. Hard work, turns out, does not manage complexity. Hard work is not enough. You need the knowledge. Commitment, also, the ability to knock your head against the wall is not an effective means of managing complexity, nor is passion. Passion, deep feeling, loving the stuff doesn't help. Knowledge is the only thing that works. And so you want to have continuing education. You want to be educating your people all the time. You want to be bringing in people who are going to train them. You're going to want to encourage them themselves to be doing training. That is really effective. That's going to improve the quality of everybody on the team. Even if you can't find really good people, you can make really good people by training them. And the obvious resistance here is, well, if they're getting smarter, then they're not doing work. But the quality of the work that they're doing is going to be so much better if they're smarter. This is a good investment. You want them to be smart. Enemy number 2, imperfection. Computer programs must be perfect. The contract we have with the computer is that a program must be perfect in every way, in every aspect, in every detail, for all possible inputs, for all possible states, and for all time. And if the program is not perfect in all of those ways, the computer has license to do the worst possible thing at the worst possible time. So that's bad. So we need for programs to be perfect. But humans are really bad at perfect. And the more complex our systems get, the more difficult perfection becomes. In fact, we cannot even recognize perfection were it to occur. We have no test for perfection. We cannot tell. But we can't find out what happens if stuff is not perfect. So one of the worst things about software is that it can change instantly from an asset to a major liability. You don't even have to modify the software for that to occur. Things can happen in the world completely independent of the software, which will then cause software systems to crash. It happens all the time. So in the 60s, we started to be aware of the problems with the computers, that writing the programs was much harder than we thought, and getting them to be correct was much harder than we expected. And we didn't anticipate that they needed to be perfect. So that led to a mathematical approach of proofs of correctness. Because obviously testing wasn't going to work. Testing cannot prove the absence of bugs. Testing can only prove the existence of bugs. We need to prove the absence, and testing cannot do that. So we need to come up with something better. So they came up with this idea of writing mathematical proofs for programs, similar to the proofs that they would write to prove the assertions they were making about mathematics. And it didn't work. And the reason it didn't work was that the proofs turned out to be more complicated than the things they were trying to prove. And so it collapsed. So that's bad. So what do you do instead? Well, we're testing now because we don't know how to do the right thing, so this is all we can do. And there's a religion that has grown up around this test-driven development, which is good to the extent that we do need to test, and we need to test well and effectively, but it's bad in that the religion assumes that testing is all you need, and it isn't and can't be, that there are problems that testing cannot find that we need to be aware of. So testing then becomes institutionalized, and we tend to grow QA organizations. There are some companies that don't trust their programmers, and so they'll set up a competitive organization, and the job of the testing organization is to try to undermine the programming and to prove that the programmers are incompetent. And so you get this adversarial thing going on, which is not healthy. I think it is much better to do both in the same team, but to incent the team to write stuff which is really good. So I want to be focusing on bug avoidance. We still need to have a testing function, we still need to find them, but it's a much more efficient thing to not make the bugs in the first place. And so we do everything we can to try to avoid making bugs. We have excellent coding standards, we have automated tools which will help discover problems, but those are of limited effectiveness. Ultimately, the team itself has to be responsible for its own bugs. And so I recommend having the team be dedicated to software entomology, where every time a bug occurs, we study it. We look at it under the microscope, we try to understand where did this bug come from, how did it occur, how can we prevent this from happening again. We do a similar kind of thing in the failure analysis of airplanes, which leads to much better airplanes. I think we should be doing the same kind of thing in software. Enemy number 3 is time. Time is a really complex subject, and it works against programmers in lots of different ways. The first one is in the economics of software, that computation happens over time. And so programmers tend to get obsessed about performance because a program is expected to do its work in a limited amount of time, and it's made up of a series of instructions or steps which each consume amount of time. So programmers are very much aware of this time budget, and that if they don't manage that budget correctly, then the performance of the program can go to hell. Except most programmers think about this incorrectly, that our intuitions about how programs spend their time is usually completely wrong. For example, in computer architecture, we have lots of levels at which things work. You know, instructions can work at the register level, which is very, very fast. Then there's the memory level, which is maybe 10 to 100 times slower, but is still pretty fast. And then there's the storage level, which is 100 times slower than the memory. And then there's the network layer, which can be thousands of times slower than the storage. And very often you see systems which are getting delayed at the network level, but you see the programmers obsessing about what's happening at the register level. So you see a lot of premature optimization where they're trying to solve the wrong problem. And they have only a limited amount of time in order to do optimization, and they waste it. They're optimizing things that don't need to be optimized at the expense of much bigger problems. So this leads to premature optimization. Often a programmer will want to make a change thinking that it's going to make the code faster. And they'll check it in without measuring. And so we don't know if it made the code faster. Usually such codes make the code cruftier. We remove generality from the code, adding more special cases, more paths, which make it harder to test, more complicated, and so a cost comes with that stuff, and we don't even know if we got the benefit. So any check-in which comes claiming to improve performance has to come with measurement. So first you measure the code to make sure that, in fact, this is where it is slow, that this is the hotspot that needs to be sped up. Then you make the change, then you measure again to look to see that it had a significant improvement. That if the improvement you got was less than what was predicted, you back it out, because the whole point of this change was to improve performance. If performance is not improving, it is a bug and should not be left in the code base, even if the intentions were good. Programmers think they're spending most of their time keyboarding, and they're not. They're spending most of their time debugging. But they think they're spending their time keyboarding, and so they will do crazy things attempting to shave keystrokes. And the crazy things they do can increase bug formation. Something that can really slow down a project is decision making, particularly when you get to a case where there are two ways to do something and the team is divided on which approach to take. You can get stalled there forever in that state. So the only thing worse than making the wrong choice is making no choice. You get suspended. And the programmers understand the consequences of either choice. Because of the way they can work with complexity, they have intuitions about what's going to happen in the future on either branch, but they can't see far enough to make the right decision, and it's paralyzing for them. XKCD had a sermon on that. So I once worked with a guy, brilliant manager. Whenever one of these cases came up, he would be solemn and he would instantly say, plan A, now go back to work. And that always freaked the teams out. Like, what if, even the guys who are advocating plan A, what if it's wrong? You can't just, that. And so they all became really careful about bringing those issues to him because they didn't want him deciding them. But the reason these things happen is sometimes you got two choices where both are fine and it really doesn't matter. And sometimes both are bad. And the reason we can't decide which one is better is because they're both bad. And delaying doesn't help in either case. Scheduling is really difficult because we can't anticipate how long something's going to take because it's not a process of development, it's a process of discovery. And we don't know how long it's going to take to sail to the new world. We don't know. So that makes it hard. So the more unknown the thing is we're doing, the less reliable our estimates are going to be. So if you're in a bank or the Social Security office or something like that, and you're writing the same program, every year you write the same program again, that's pretty reliable because there's nothing, it's routine. You're doing the same thing over again. But most of what we're doing is innovative, right? And when you innovate, it means you're doing stuff that's unknown, at least to the team that's doing it. And that means you're in that territory, which means that estimates about how long this is going to take are going to be really unreliable. And that's just the nature of it. Another place where programmers have to fight with time is with sleep. There's a tendency for programmers to not get enough sleep. The only macho thing programmers do is stay up late. So they'll do that. And in fact, management will reward them for doing an all-nighter. You shouldn't do that. Sleep deprivation severely degrades human performance, and that's even more true for programmers. So we want to encourage them to sleep. So send them home if necessary. I would have a place at the office for people to sleep. If someone is burned and needs to lie down for a while, that shouldn't be considered a bad thing. You know, have a quiet place where they can go and do that. And some managers will get really upset with that. You don't look busy. What am I paying? I'm paying you to look busy. No, you're not. You're paying them to be productive, and you can't be productive if you're burned out. Enemy number 4, mismanagement. You know, so they love programming, and they want to program, but they hate it when forces cause them to make bad programs. So everybody has fantasies about winning the lottery. And most people, you know, what would you do if you won the lottery? I'd quit my stupid job, and I would move away, and you know, they got some plan they're going to do. If you ask a programmer, what would happen if you won the lottery? Well, first off, it's never going to happen because programmers are really smart, and they know the odds, right? You know, it's not a fair game. They're not going to do that. But hypothetically, if a programmer won the lottery, I'm going to start a software company, and I'm going to hire all my friends, and we're going to write great software. You know, their dream is to be able to write software and not be mismanaged. Their dream is not to stop working. They want to be working in a place that'll manage them well. Unfortunately, that dream is going to go bad because they will mismanage themselves and they'll be miserable. But that's their dream. That's where they want to go. So we can help them to be more effective if we can manage them well. So most managers have this sense of urgency. We've got to get stuff done. The clock's ticking. There's competition out there. Boom, boom, boom. Everybody, and they know that. I mean, you should make it clear to them, why we need this. They'll understand. But the thing is, software will take some time to make. And unfortunately, we can't always predict how much time that's going to be, but it will take that time. And if you try to make it take less time, it will take more time. And so constantly be saying, urgent, urgent, urgent. It's just, can you turn the alarms off? It makes it hard to concentrate. I'll get it done, just let me do my work. So most of the things you do to try to make development go faster will make it go slower instead. So there are things that you can do to make it earlier than later. One is to add staff, but you need to add the staff at the beginning. If you add the staff in the middle of the project, or even worse, after the project is declared late, adding new staff will actually slow the project down because the new workers will distract the previous guys, and so their rate of development actually decreases. You can make things worse by canceling continuing education. We're behind schedule. We don't have time for these luxuries like being smart. So forget being smart. We're going to do that instead. You need to make them smarter. You require that they hit intermediate milestones. And this comes, again, from misunderstanding of how software works, that we've got a milestone, we'll be at that point, then that point, and then we'll be there, and then we'll be done. And the software doesn't go like that. And so trying to put a linear thing on it doesn't get you to where you want to go. So what will happen is your programmers will work really hard to try to get to the first milestone. And they will make compromises in order to get there. And those compromises set you up for failure later. And then the next one, there are more compromises and get worse. And then eventually you get to the wall where you just can't get there anymore. Trying to force them to be on a regular cadence actually sets them up for failure. You can extend the workday. You can say, we're late. I don't want to see anybody going home. Everybody's working late tonight. We've got to get this done. And what you're going to do is burn them out. And they're going to be working exhausted. And programmers cannot work well unless their brains are clear, because it's all happening in their heads. And if their heads aren't working right, they're not going to be productive for you. And then the worst thing you can do is call panic mode. That's, all hands on deck, everybody stops, nobody goes home until this thing is done. We're here for the duration. And as a manager, you can feel really good about this. Like, I'm taking charge, I'm being decisive. I'm being a manager, and look at this. I'm getting these guys to work 24 hours a day, but I'm only paying them their regular salaries. I'm a management genius. And while that's going on, I can lecture them, we're only doing this because of your failure. There's something so wrong with you. You should think about that while you're doing that and not going home and seeing your families and all that. But actually, this is the clear sign that management itself is failing. If management is doing its job, this should never happen. So what you need instead is talented staff. You need clear, stable requirements. Software, because it's so flimsy, you'd think, well, we changed our minds on what we need. We want something else instead. Shouldn't be a problem, except that can really destabilize a software project. And if you want to get the stuff done quickly, you need to make sure you've got the requirements right going in. You want to give them minimal distractions. You want to have a focus on quality. That quality, not lines of code, not completion, not milestone. Quality is the thing we're shooting for. If you get the quality right, that's your best chance for getting the rest of it. And you need to give them sufficient time. We always want to give programmers too little time to do their work, and you know the consequences of that. Now, sometimes we get to the point in a project where we've gone through panic modes, which tend to cause the huge reductions in code quality, and the code has gotten so bad that on each sprint, we're making no progress. We're barely keeping up with the bug fixes. We're not getting the new stuff in. We're stuck. We're just not moving anymore. And it's not that the team has suddenly become lazy and stupid, it's that the code base is now working against them. That the code base has dropped to such a low level of quality that it does not accept improvements anymore. And there are some things you can do. One is you can stop and do a refactoring and say, we're not going to add new features for a while, we're just going to get this stuff clean so we can get up to a place. But eventually you may reach a point where the code has gotten so bad that the only option is to start over. And management does not want to hear this, because we've invested so much time to get to this point, we don't want to have to go all the way back to the beginning and do this again. That would be admitting failure and incompetence, and we don't want to do that, so just keep going. But sometimes this is the only way to go forward, and it's not so bad, because now, when we're starting over, we should make it very clear the requirement is to get back to where we are right now in the best way possible. That in writing the code up to this point, we had not yet discovered the right way to do it, but now we know a lot more about the domain, so we can cover that same ground much more quickly. We don't have to discover anything because we already know it, we have that experience. The place where projects can get into trouble is the second system syndrome. That if instead of trying to retrace our steps to get back to here, but doing it with a clean code base, they instead are given a blank slate to do the best possible architecture. We're now back into the undiscovered country again, and the likelihood that we're going to fail is extremely high. So it's safe to do a restart only if we're covering the same ground that we already understand really well. In that case, it could be a tremendous investment, because now we've got a clean code base, and now we can start iterating again and be very effective. One of the most important things you can do as a manager is provide protection, that you're running interference for the team, that the company does not understand programmers, and so they're going to ask you to do crazy, stupid things, and you have to not let it happen. You need to defend your programmers. They need to understand that you're watching out for them. You're going to keep them out of the stupid meetings. You're going to keep them from getting whipped around. You're going to keep the requirements from getting changed on them. You're going to give them the tools that they need to do their work. You're going to let them be the gods that they are, because that's when they're happy and productive. So there's this, that's not compatible with the business reality. The business reality says you need to look at the big picture. And the big picture is we have requirements which say we have to have this software done on this date in order to deliver in this way, and that's just the way it is. So you need to do that. You can't be working in this fantasy world that programmers live in where stuff takes the time that it takes. But it turns out the reality is that that reality doesn't work. That software is this different thing which comes with different constraints, and if you try to manage it like manufacturing, you will fail. And managing a process to failure is not consistent with reality. So if you want to get your team behind you, if you want them to understand that you are looking out for them, this is what you tell them. If it's stupid, we won't do it. They will love you for this, but it's got to be true. I know managers who've said, well, if we're doing it, it's not stupid. That's not the same thing. You know, they've got this gift, and they're willing to share it with you, and in exchange, they get some money, but more than that, they want to be able to make good stuff. It is soul-destroying to a programmer to have their project canceled or to have it misused. They don't want that. They want their stuff to get out there and be used by people, because that's what they're doing it for. They don't want to be doing it for nothing. They don't want their gifts wasted. And this is very compatible with that. So, you know, but you got to mean it. You know, we can put it on our t-shirts and we're going to walk around in public and not be embarrassed by this, that this is who we are. Also, they'd be very happy if you say, we won't ship crap. They know if the software is good enough. And, well, actually they don't. They're optimists, and so they'll think that the software is ready to go before it's ready to go. But if they're telling you it's not ready, you better believe them, because they know what's going on in there. I once talked to a manager who said, the problem with my programmers is they're perfectionists, so they won't let me ship the software. You should be listening to those guys, because they know something about what's going in that code. I have never met a programmer who was a perfectionist at that level, who would never allow code to be finished. they get as sick of it as you are, and they want to put it in the can and move on to something more interesting. You got to watch out for sabotage. This is where bad stuff gets leaked or snuck into the code base, and that will lead to big problems in the future. Much of the sabotage is unintentional. It's because there's not an adequate focus on quality, and so bad stuff gets into the code base, and it hangs in there for a while, and eventually turns into bugs and turns into failures, which could, in some cases, destroy a company. There can also be security exploits, in that everything that we do now is potentially exploitable, and so we need to be aware of the security implications of everything that we do. And this only happens with continuing education. Some sabotage will be intentional but without malice. The team might decide that there's a particular approach that we don't want to do because it's too dangerous or not well suited or whatever, but there's a programmer who really wants to do it anyway and does it that way. And we'll sneak the code in because they're bored with what's going on and they want to make the project interesting for themselves. This stuff can then turn into bad stuff later. And then the worst thing is intentional with malice, where you've got someone who wants to hack your company from the inside, who's putting trapdoors or other leaks into the system so that after he's fired, he's going to be able to come back in and do bad stuff. So you want to be looking out for this kind of stuff all the time as well. And the most effective way of dealing with all of these things is with code reading. Enemy number 5, themselves. So programmers are smarter than they look, but they're not as smart as they think they are. So your job is to help them to become as smart as they think they are, and that's achievable. And if you do that, you will be rewarded. They will become very productive. So something that a lot of programmers suffer from, same thing humans suffer from, informed ignorance. That we all have a tendency to believe that what I know is adequate for deciding the decision in front of me. In fact, the reason why the decision is difficult is because it relies on stuff that we don't know. So programmers will get very confident that they have enough information in order to solve something based on their own experience. And in fact, they don't. And the best way to circumvent this problem is with the continuing education. They tend to buy into cults and fads. So there's some new software trick of the day, and suddenly they all want to do that because it looks cool without properly deciding, does this really make sense in our enterprise? Is this something that we should be doing? So you want to teach them to be better people. And you can do that first by leading by example. So if you are impeccable in the way that you operate and you demand that they work at your level, they will respect that. Teachers. Teach them to say, please, thank you, sorry. That's really important, and most programmers aren't aware of that. They think it's a waste of time. You know, they look at human interaction as a protocol, and those are just noise words which are not contributing anything meaningful, and we can be more efficient if we simply leave those words out. That's another of these cases where they think they have enough knowledge to properly decide something. And programmers are so smart, they'll come up with models like that all the time. And based on what they know, they're right, but they're not aware of what they don't know, and so they're wrong. So am I saying you should treat them like 3-year-olds? Yes, you should teach them like 3-year-olds. You should make them say please and thank you and sorry, because that makes it better for humans to interact. That's just how we are. You should teach them to argue correctly. They will sometimes get very emotional about stuff and argue from an incorrect place, and you want to keep everything factual and logical. They think that's what they're doing, but they're not. So you need to remind them to be logical. And you need to remind them that what we're producing is for the people, that we are using our godly gifts in service of mankind. We are creating useful gifts that we give to the world. Never forget that. There's a tendency for some programmers and some teams to have contempt for their users. We don't want that. We cannot tolerate that for a second. So we want to remind them that everything we do is for the people. Usually we want the programmers to be in one place so that they can communicate effectively, and that's usually going to be an office. But programmers are creatives, not office workers. They look like office workers because they're sitting in front of screens and typing on keyboards just like other people in an office. They look like secretaries, but they're not. They're doing completely different work. And in fact, offices are hostile environments for programmers. One of the most effective states a programmer can get into is called flow. Flow is this heightened psychological state in which you become extremely focused, extremely productive, extremely creative. It feels good, it's wonderful. It's something artists can do, programmers can do it. You want them to do it. You want them to do it. The problem with flow is that any distraction takes you out of it, and then you're back down in the mundane world. Being in flow is so important that Microsoft had a policy that every programmer got a private office, so that when they're ready to flow, they can just go in there, close the door, they can focus, and they can get stuff done. That's one of the really nice things that happens when the founder of your company is the world's richest programmer. He goes, yeah, these guys are worth it. We want them in private offices because they are that much more effective. Another approach is you want to emphasize communication. And you see this in startups. So startups can't afford to have private offices for everybody. So a startup will generally have one big room and all the programmers are in that room. And while it's hard to flow in that environment, they communicate really effectively. And so much of what we're doing is a process of discovery, and they are discovering together. They're vocalizing as they're working, and the amount of communication that they can accomplish is amazing. And you get really great benefits from that. So startups have a lot of natural advantages. One is that they tend to not be mismanaged, and another is that they operate that way. They operate in bullpens, and anybody can do that. I think the worst possible thing is to put them in cubicles, because in cubicles you have the distraction, which means you can't flow, and you get the noise, which means you can't communicate. The only thing worse than cubicles is open plans. Open plans must work for somebody, but I haven't figured out who that is yet. It certainly doesn't work for programmers. It's just distracting. You've got lots of teams in the same place. Some of the teams are doing completely different work. Some of the teams are the kinds of operations where they want to be doing a lot of talking. Generally, you're putting people in rows, so the person on that end is not communicating with the person on that end. It's just the worst possible environment to put programmers in. Yeah, the open plan, awful. So I thought a lot about ideal. You know, if I were to start a new software organization and I get to do it right, what would my office look like? So this is what I came up with. I want to have large project rooms, bullpens, where a project will get its own room with their own door. They get to use the room however they want. The walls are covered with white boards all around, because it's really important for programmers to be able to write on the walls. That's one of the most effective ways that they communicate, because much of what we're doing is not expressible verbally. And one of the problems with cubicles and open plans is we got rid of the whiteboards, so there's no place for them to communicate. And so without that communication, it's much easier for misunderstandings to develop. I want to have lots of meeting rooms. I want to be able to go to a place and meet. So if a couple of people need to go off and hash something out without disturbing the rest of the team, they can do that. If we need to have a liaison with another team, we can have a meeting in one of these separate spaces. I want to have round tables, especially in the big rooms, because round tables make communication with everybody in the room easier. I want to have classrooms, because it's for the continuing education thing. We've got to be learning all the time, and I want that reflected in the architecture. So we can use those classrooms to be teaching ourselves. We can also make those classrooms available to the public at night, so we can sponsor meetups and bring people on the outside to see what we're doing and also to learn from what they're doing. That's all beneficial to us. It makes us look cool. So when people come in from the outside for the meetups and see what we're doing, they're thinking, wow, I want to work in this place. I want a library. Now, books are sort of obsolete, so we don't see libraries much anymore, but I want to go out and buy antique computer books and fill them up on shelves, because there's something about a room that's got books in it which tells you this is what this room is for. that this is where we're going to be silent, this is where we're going to be intelligent, and you go in the room because you want those things. It's really important to have that kind of space, because sometimes you just need to be able to get away from everybody else and just focus. I want padded cells. I want a place where people can go and be noisy without annoying the hell out of everybody else. That sometimes you got a pair, and they're noisy when they're pairing, and they distract the hell out of everybody else, and I want a place where they can go and do that. I want a common place, like a diner where we can get together and eat. And I want booze there with power plugs and food. I mean, Google had this brilliant idea. You know, if you're keeping someone in your place for 8 hours, it'd be impolite not to offer them a meal, right? It's just, why are we saving money on food? That doesn't make any sense. You know, so keep them all fed and happy. It becomes a place where they can get together and talk, which is important. The diner is a place where the Ronin can hang out. Well, when they're between projects, they can be there and kind of spying on what everyone else is doing, which is another mode of communication. The best CTO I ever worked with gave up his executive cubicle, instead took over a booth in the cafeteria so that everybody could see him. And you know, he was there and approachable and accessible. Most CEOs are locked up in meetings, you never see him. I thought that was brilliant. And a bunk room. I want a place where people can go when they're burned out and sleep. In some cases, you might have programmers whose lives are not working on the outside and they need a place to hide out. Let them do it at your place. You will actually get benefit. I mean, there are stories about Steve Jobs sleeping at Atari where he was working. You know, good things could happen unexpectedly from that kind of stuff. And a shower. Oh yeah, you want to have a shower. And you want them to use it. You know, because programmers, again, have this weird logic where they thought, well, the computer doesn't care what I smell like, but, and that's probably true, but the rest of us do, right? And so you want to be able to tell them, you're done, hit the showers. You can't do that if you don't have the showers. So you want to have that. Yeah, we should have hygiene standards. We have a big problem. We can't get enough women to work with us. And we need them. We need women working with us because they bring perspective and talents that the rest of us lack, apparently. And I've always thought, you know, if we had, you know, hygiene standards and a dress code, maybe that would work out better. And then daycare. A lot of our guys will have kids. I want to have a place in the office where they can bring them. I want the work-life thing to really work. And so I want to set up a place in the middle of the area where we can see them, because we know that they're safe and taken care of, and we can see them all the time and be reminded, why are we doing this? I think professionals should own their own machines. So most companies will want to issue crappy machines to their programmers. No, I'd say don't give them anything. Let them go out and buy whatever they need, and let them hook it up to the network and be good at that. Most IT departments are afraid to let anybody hook anything up to the network because they're afraid, because their network configurations are so hopelessly incompetent that if any machine hooks up to it, then everything will be compromised. Got to fix that, right? If we can't trust our own people to hook their own machines to our network, we're doing it wrong. So that brings me to the end. I just want to end with one piece of advice, and I'm really serious about this. Don't forget, please don't make bugs. Thank you. So what time do we finish? Do we have time for questions? I don't know what the schedule is.
Yeah, there's plenty of time, Doug.
Okay, so there's a microphone here if you want to ask a question, or if you can get my attention. Yeah.
What do you do if you have to change the requirements? Suppose you're doing Android and you thought you were doing BlackBerry and now you've got to do iPhone.
Yeah, what happens if you have to change the requirements? Then you have to change the requirements and you're going to take a hit. But you shouldn't be able to change the requirements and think you can get the different thing in the same time. That's not going to happen. Yeah, it's going to take longer. Yes?
What's your suggestion for measuring people's performance?
I'm sorry?
If you have to measure a program's performance, what do you do?
Measure a programmer's performance?
Program.
Or a program's performance?
Program.
I'm sorry.
Measure the performance of the programmer.
Observe what happens in the code readings. Observe how he interacts with his other team members, and you'll see a normal kind of ranking is going to happen. You know, people are going to defer to the guy who's the 10, and you're going to see a lot of hand-holding for the guy who's a 1. That's going to become apparent. The thing you don't want to do is to keep score, because they will then game the code readings, and then you lose all the benefit from that. So you don't want to do anything that's going to be gaming. Back there.
So I didn't really get your take on QA tools. Do you think you need or do not need QA?
We need QA, but I think it should be integrated with the team. I don't think it should be in a separate organization, because the QA team is learning things which needs to get fed back immediately to the team. And if they're in separate organizations, that doesn't happen. So I want them to be working together cooperatively, because they all want the best outcome. I don't want the adversarial thing that you see in some organizations. Yeah.
So what do you think of tools that are coming out, for example, from Atlassian, Jira, and Confluence? Do you think they're useful at all, or garbage, or?
Tools are great, but I think the culture is more important. So, you know, putting good tools into a mismanaged situation is not going to make it better.
It's off the top management wants some numbers. Show me how you measured that.
Again, there are a lot of managers who want to manage to numbers. And I don't think software is something you can manage to numbers. I don't think it works. So your job is then to game that system, right? That's hard, but that's what they're paying you for. Yeah.
What's your take on quarterly performance reviews?
Yeah, performance reviews are generally a waste of time. That I want the team to constantly be aware of what's going on, so we're meeting every day. So waiting for a quarter to tell somebody this isn't working, I don't think that's a good strategy. I want to be doing that all the time. And I've become convinced that performance reviews are really something to distract us from what we're actually being paid for. That, you know, as long as they can make us aware that it's not about salary negotiation skill, it's about something else, that allows them to keep salaries low. Yeah.
How do you compare your daily code reviews versus just incremental ones where anyone promotes something, you review it before it gets into the code base?
That's better than not doing it at all, but I want to be doing it every day. I want the daily to be part of the flow of work. That every day, that our work is so important, we respect the work so much that we're going to look at it every day, all of us together. We're going to all get together and look at it because that's what matters. And it matters to me as someone on the team to be looking at what you're doing, and I want you to be looking at what I'm doing. And we can be mentoring each other as we're doing this. So the really strong programmers are teaching by example the more junior guys, and you know, so that kind of mentoring doesn't happen in occasional reviews.
This wouldn't be occasional. This is every promote. You promote code, you're
Yeah.
doing a review.
Yeah, I want to do it every day.
This is 10 times a day.
That may be a bit too much. Yeah, I think once a day is the right number. Yeah.
How do you deal with like mixed cultures of business cultures? So you have the manufacturing side, the cubicle mill, then you have the programming team within an industrial type business. And you're trying to create two different environments.
Yeah, it's really hard. And you know, it could be, you know, if management decides the most important thing is not to create resentment for those guys, so we're going to oppress everybody equally, that's fine, but it's not going to get you the productivity that you need. So maybe you want to put them away in a different place where people don't see them, or what. But the worst thing you can do, I think, is to put them all on the same floor and just have them annoy each other. Because the working styles of programmers versus other people are so different that programmers can be incredibly annoying people. And, you know, so, and a part of me doesn't like that, because there's a tendency in programming teams to be so disconnected from the rest of the company that we don't really know who our customers are or even know what our product is, and that's unhealthy. So I want them to be integrated with what's going on, but just putting them in the same space doesn't accomplish that. Something that I'd like to do is to rotate people, everybody in the company, through customer service. You know, I want every year everybody spends a week on the telephones or making customer calls or whatever you're doing in order to get in front of customers and see how they see us. That one of the worst things that happens in software development is a lack of empathy for the people who actually have to use our crap. And so we'll make bad stuff, not intending to make bad stuff, but simply we're not aware of what human beings need in order to be happy and effective. We have this mythology in software that we're making the world a better place, you know, ignoring all the obvious evidence to the contrary. But we should at least be making the world a better place for the people who are using our products at the moment that they're using them. You know, we should at least accomplish that. And so that I think we can do by cycling people through customer service. And hopefully that'll give them a view on what's going on. Also, we can use our educational context. You know, we got that classroom, a huge classroom. I want to bring the managers of the company through there. You know, have each of the vice presidents come in periodically to give a report on what's going on in the company, because we need to know that. We should share it. Yeah.
So there was no ping-pong table or football field or game in your ideal office. What do you think about that?
I'm sorry, there was no what?
Game room.
Game room. So, yeah, I don't know about the game room. Maybe, like when I worked at Lucasfilm, we had an arcade room. So we would get coin-op games delivered to us. And we spent a lot of time on them. And we often had conversations around the machine. You know, people would line up behind Marble Madness, and we're talking about stuff as we're doing it. We were also in the business of making games, so we had a good excuse for doing that. And so generally, yeah, that kind of recreational stuff, I think it's a good idea. I'm not a foosball fan myself, but, you know, whatever. Yeah.
So on the other end, when funding is cut, then you have to cut some people. What things would you recommend to look at to decide when to cut?
That's a really good question. So what happens when you have the cuts, when you have the rips, the layoffs? Generally what happens is we lay off the wrong people. We let go of the people with the bad attitudes who are actually the 10s, and we keep the Wallys. And we keep the guys with good attitudes who don't mind being mismanaged. They're just so happy to be getting paid, and that nobody's looking closely at what they're doing. It's good for them. And so yeah, I want to get rid of those guys. It's really hard because especially in big companies, you tend to get all these layers of middle management, and those layers are optimized for protecting middle management and not for accomplishing any of the goals of the company. And so while I'm riffing everybody else, I want to wipe out that whole layer as well. Basically, I want to fire everybody, but I guess that's why I'm not a CEO anymore. Yeah.
What is your criteria for people, and how do you measure the software quality?
So yeah, what's my criteria for talented people and how do I measure their work? So let me give you an analogy. So I worked at Lucasfilm, and for a while I shared an office with an art director, and his job was to build an art department at Lucasfilm. And he was a brilliant artist and an even better art director, and he would bring people in, and one of the things, or what he would always do is have them bring in a portfolio. And he would look at what they did. You know, can they draw? Do they have an eye? Do they have a style? He didn't care what software they knew, because there was not a high correlation between software skills or usability skills and talent, that anybody can learn to use a piece of software. And most of the artists that he was looking at had not used computers yet at that time. This was in the 80s. His assumption was, we can teach them to use the software. You can't teach someone to be an artist. And he put together a brilliant team. And so that has influenced the way I look for programmers. So I want them to bring in a portfolio. I don't want to look at any confidential code, anything that belongs to a current employer that they can't show me. But I want them to come in with some code, and I want to look at it, and I want to see the quality of it. And I want to see that they can defend it, that they can explain what it's going. Now that we got Google Code and things, it's easy to find out if they're lying. You know, if they're bringing in some code that's not theirs, we can figure that out pretty easily now. And you know, if someone comes in and they don't have a portfolio, so I'm happy to let one of my competitors hire him, because I want someone who is a god, someone who cannot stop writing software. I want someone who has that gift and cannot stop using it. And so the good programmers are writing at work, but they're also writing at home. They're writing while they're on vacation. They can't stop doing it. They love doing this. And I want to see that. I want, when people come in and interview, I want them to demonstrate that. Okay. I'm sorry?
What is your metrics to measure the software?
I have not found any effective measurements. The metrics do not work. I'm hoping someday someone will figure out a metric that does work, because that would make talking to management a lot easier. I have not found it. Last question.
If I'm working in a company that has some of the global detection, is there anything that I cannot change the management? Is there anything that I can do as a programmer? If I like to see the other programmer trying to do it?
Yeah, that's a really quick question. So if you're working at a mismanaged company and you're a programmer, what can you do? Well, basically, this talk was for you. That what I'm trying to do is to give you the tools to help your manager be a better manager of programmers. That's the first step. You know, that's all I got. Thank you, everybody. It's been great.